I would like to invite Rishi Nayar. He's a software director and part of GE Transportation. So,
Yeah.
welcome, sir.
How's everyone doing? Fine. How many people like me are wondering what's for lunch? No? Because we are running a little late, right? So I'll try to keep it short. So, okay, like I said, I'm Rishi Nayar. Ignore the spelling here. So what we do here in transportation is, one of the things that GE Transportation and GE as a company has been undergoing what we call a digital transformation over the past few years. So every business in GE, aviation, transportation, healthcare, we are all trying to kind of turn ourselves into this digital industrial company. And so and every business is going through that same phase, right? So transportation is doing a few things on our own, to try to go beyond what we traditionally is our big business, which is, building locomotives. In transportation, that is the biggest chunk of our revenue. But, what can we do in terms of marrying that whole mechanical side of things with the digital side of things? And what kind of outcomes can we get from there? So I've called this smart locomotives and self-aware trains, and so that's the goal that we want to get to, right? If you can have self-driving cars, self-driving trains should be much easier to do, right? They don't have to go all over the place. So, so before we start, right? So the landscape that I'm showing here is essentially the freight landscape, and this is primarily again at this point US based or US focused, but essentially it remains the same, any part of the world. So essentially all freight is all about moving stuff from one place, from the shippers to the receivers, right? And so if you look at it, there is the first mile kind of thing where you have your trucks, small boats, barges, any kind of thing, right? Anything that moves it from, say, the shipper's location to, the short haul sort of lines, which is covering maybe the next 250 miles, from where it actually goes into these things called the intermodal terminals or the yards. And from that place, it actually changes. It might go from a truck onto a long haul train or from a ship to a long haul train. So those are sort of, even at ports, you kind of see those sort of, that intermodal activity. And then once you get on to the long haul, that's where, it really crosses the country. It goes, from, one destination to, something thousands of miles away. And then once it reaches that other point, you have the reverse effect, right? Intermodal back to short haul, back to, last mile to the receivers, right? So, sorry? 3PL stands for third party providers. So it could be essentially third party logistics, right? So it is just you just rent some guy who has a truck and say go deliver this at the short haul line, right? So what is the outcome we want to deliver with well, not just IoT but in terms of getting smarter, right? So I think Guru just mentioned the 1% thing, right? So even at GE we have a phrase called the power of one or the power of 1%, right? So as you see here, right, a 1% improvement in asset utilization, right, can result in savings or additional revenue of up to $800 million. Improvement in car dwell. Car dwell is if you have these rail cars that are sitting in yards, if you can optimize how quickly they get formed into trains and how, if you reduce the time between them coming into a yard to leaving as part of some train, $2.2 billion, right? I mean, it seems like very large numbers, but if you look at the size of the rail industry, right, these sort of improvements do yield, really big numbers. Same thing with network velocity. If you can increase the speed of your trains on the network by 1 mile per hour, that's a $2.5 billion increase in revenue. And fuel efficiency, same as with aircraft engines, with locomotives, right? If you can reduce the number of or the amount of fuel you use, again, that's just directly going to hit your bottom line, right? So these are some of the outcomes we want to kind of reach, right? When we do IoT and when we do the smart train sort of initiatives. So the way we want to get there is we work at 3 levels. So one is at the train and the locomotive level. What do we do to improve efficiency there, reduce your asset downtime, make sure you don't have unexpected failures. Then you go one level up to the network. The network is how do I how do I get that network speed up? How do I make sure there's no congestion at different places? How do I keep track of what's happening with my supply chain, from the sender all the way to from the shipper to the receiver? And then finally, one level above, and this is a new sort of business we have started this year, where we are actually working directly with customers, not necessarily just for, for your rail optimization, but optimizing beyond that, looking at your entire operations and figuring out, hey, what can we do to help you, where are the bottlenecks, sometimes even trying to help them identify if there is a bottleneck. There may be times when they don't understand, where they could make some improvements. So the first thing there is train performance, like I mentioned. So with train performance, there's a few different things that we do in train performance today. I'll talk about 3 specific items here, right? So one is GoLink. So GoLink is like it's like our mobile communication device or the edge device on the locomotive, right? What it does today is it'll capture all kinds of data from your sensors in the locomotive as well as in the entire train, from your rail integrity monitor sort of sensors. It will then actually, it has multiple modes of sending that information back either to a RMND, which is a remote monitoring and diagnostic center, or if you can do some sort of analytics right there on the train, maybe provide instant sort of feedback to the operator for very emergency sort of things that need to be taken care of, right? We already have that on the and GoLink again is it's been there for some time, but we are adding a lot more capabilities as we try to get to this point where the train starts being able to take a lot more decisions on its own. Trip Optimizer is our play towards reducing fuel efficiency, or increasing fuel efficiency, sorry. And so again, this is a solution that's been around for a while. The way it works is if you give it, this is my start point and this is my end point, it will take into account the entire topology of the, of the route that you're going to take. And it will figure out at this point, I should speed up, here I should slow down, I should brake here, I shouldn't brake there, all those sort of things. If I'm going on a curve, what is the speed I should use? And what we have actually seen is we have saved about 90 million gallons of fuel at this point, diesel. And it's sort of an autopilot. So once you hit the start speed, which is about 12 miles per hour in the US, it actually takes over the train. Right? So it interfaces directly with the control system software, and it drives the train for you. Right? So the operator doesn't really need to do anything, unless there's a need to override. Finally, Locovision. Locovision it's one of the new offerings that we have, right? Where we've got these high definition cameras, both inside the cab and outside the locomotive. And so the train basically goes over tracks and all those things every day, right? Now with using this camera, and we've had cameras before, where some of it is usually just to play back and make sure if there's an accident, what happened and all those things. So then what we figured is if it's already there, why don't we make it a high def camera, use it to do things like checking all your wayside assets, are they looking fine, is there a tree covering of signboard, is something looking broken? So it can do all that kind of video analytics. It can actually check your track to see if there's a break in the track. Because you can so we do some things like some amount of real-time video analysis right there on the locomotive. And see again, if you see a break, like 100 meters away, there's not much you can do. But then at least you can, you may be able to at least send that information back, use it to create a new work order so that someone can come out and take a look at it, right? So, and then Locovision also helps you monitor the driver, for example, for fatigue, for alertness, what are they doing? Are they doing the things they are supposed to do, right? So a lot of that video analytics, which can help you, again, get better outcomes, both from a safety and from a, if you can try to fix something before it breaks, the cost of, it's like writing software, right? If you, fix the bug before it goes out to production, it's 10 times cheaper than trying to fix it after it's gone out into the world. Right? There are other things also. You have your RMND, you have things like Locotrol, which lets you control multiple trains using, from one train. This Power Advisor, which we'll touch on in a bit, right? So that was at the train and the locomotive level. So now if you go up one level, there's the, the whole ecosystem in the rail network, right? So that ecosystem includes, the shippers, the yard planning, the terminal operating systems, wayside asset management, things that go just beyond your train and the locomotive, right? So some of the bigger, so sort of offerings we have, there is something called Movement Planner. So Movement Planner, actually what it does is, again, given a start and an end point, it will figure out what is the best route to get from A to B. And it will also reroute every 30 seconds or every 60 seconds, it will regenerate the route. So in case you're driving somewhere and you find something, well, someone reports that, okay, there's a tree fallen on this, on this track. It will immediately try to reroute and go find a new route so that it can, you can avoid that thing. It takes care of things like making sure two trains don't show up at the same junction at the same time. So it'll recommend you go slower, you go faster, right? So it does all of those things. Again, it's got a lot of intelligence within it, right? And it does, like it says it does real-time optimization of the network. So we talked about 1% improvement. In general, our customers are seeing up to 10%, on average 10% improvement in, in network velocity. Similarly, smart intermodal terminals. So intermodal, as I mentioned, is a place where things might go from a truck onto a train or vice versa, from a train onto a boat. All kinds of different modes of travel is where it kind of that changeover happens at an intermodal terminal. So we are building something there now on our new platform. So that to make it, typically these things are installed at the intermodal site in the yard or wherever the terminal is. We are trying to build cloud-based solutions for that, which can not only help that particular terminal, but use that data to see if there's ways in which we can learn from that and also use it at other places. Right? TMS is again transportation management, where that's the place where it's kind of the overall management system for a railroad. Keeping track of all the trains, keeping track of all the assets, what is happening from an overall perspective on their network, right? So, and the third piece, which I mentioned, which is even one level above, your operations management, is going and talking to customers to find out what are the challenges they face today, and how can we help fix that, or try to alleviate some of those issues. And what we are trying to do is we are trying to use analytics for doing that. So one reason for this is GE as a company has been doing analytics for a long time. A lot of the physics-based analytics, right? So everything that we have, like your aircraft engines, locomotives, turbines, gas turbines, all of those things. There's a lot of experience already in GE for doing analytics. We are now marrying that experience with big data analytics to see, understanding the domain and trying to use that understanding with our expertise in analytics to figure out where can we add more value, right? So it may not necessarily be something rail related. So for example, we are working with some ports to find out what kind of operations they have, what kind of challenges they face in terms of optimization, and where can we how can we kind of help with that, right? So it is all based on data. Some of the offerings we have on performance analytics is this Expert and Alert, which essentially monitors it runs in our RMND center, the Remote Monitoring and Diagnostic Center, and it is constantly monitoring the train for health checks and all those sort of things. If it finds that, hey, maybe there is a chance of a failure happening in the next 100 miles, let the operator know. Maybe you should just go slower. You might arrive a little later, but coming late is a much more desired outcome than having a breakdown. Similarly, Power Advisor helps you figure out, and you might think this is kind of odd, right? But it is apparently a fairly regular problem where you might either overpower or underpower a particular train by picking the wrong locomotive, right? So making sure that you put the right train on the right locomotive based on everything, based on not just the load it is hauling, but also the route and the topology that it will take. That kind of, it requires a fair bit of analytics at the back end. Analytics of first figuring out what you need to have and then figuring out what is available. So sometimes you may need to actually put in two smaller locomotives because you may not have a bigger one available, right? So being able to provide all those sort of insights helps to again smoothen the operations for the railroad. Wind blowover is a pretty interesting project we did recently, where there are, especially in the US, right, there are areas where sometimes if the wind blows at like 50 miles an hour, right, and it hits it perpendicularly at on the train, it actually blows things over, right? So how do you then figure out what is the, but if you were to go at a different speed, or if you knew that, okay, hey, there's a high wind event going to happen, say, in the next half an hour, you could probably say, let's stop the train. And even then the train could get blown over, but the cost of cleanup of a stationary train is actually sometimes magnitudes lesser than a moving train. So for example, if you're going over a bridge or over some water body and the train blows over, there's a lot more cost involved for the railroad, because of the whole EPA and the environment effects and all that. So being able to predict that, accurately can actually result in savings of tens of millions of dollars, at least for the one customer that we work with. Right? Okay, so how are we going to build all this, right? So we know what we want to build. So our kind of play is this new platform called Predix, which is essentially it's a cloud platform for the industrial internet, like it says there, right? And so what we have done there is we kind of figured that there are offerings like Azure and AWS and a whole bunch of other things out there. But for an industrial sort of company, the kind of loads that we want to run, the analytics that we think need to be supported, the ability to take in, like large amounts of data, ingest large amounts of data, but from many disparate sources, right? So all of those things kind of we felt requires a new kind of platform. And just like Bala mentioned, right, even our aircraft engines, on every flight, they can generate up to 500 gig of data. Right? So what do you do? How do you ingest all that data? You may not be able to use the standard mechanisms for doing that. Right? So we said, this is our machine to cloud platform. It's got three main aspects to it, right? So first is the communication at the edge, so which is where you have something called Predix machine, which can run on the edge on your asset or within your farm or in your factory, collecting data, making sure it does a little bit of analysis and cleaning up right there, and then sending it all back into the cloud. The cloud piece is where, that's kind of the heart of the whole system, right? It has the heavy duty, it's got out-of-box analytics available, it's got the ability to create applications, you can build your own applications. It has security, it has, things for, again, like I said, managing huge volumes of data. It's all built on top of Cloud Foundry, the Cloud Foundry stack. And so essentially that's what we are building. It's in our own data centers. The communication is all secure, because that is a big, in some industries that's a regulatory requirement, that any data you send has to be sent securely. But customers themselves say, we are not just going to send it over the air, right? So we support a whole number of different security standards. And then the final thing, right? So once you get the data, you analyze the data to create your applications, and then you have the way to consume the data, right? So you can build web apps, you can build mobile apps, and all of that is again supported by the Predix platform. So we give you a way to build your own apps, how to deploy them, the whole CI/CD piece, maintenance, all of that is provided by Predix. So that's the basic GE offering. What do we do as transportation, right? So for transportation, we are building something called the Rail Operating System, and that is a digital framework built on top of Predix. So what we do there is we start with if you look at the bottom, there's something called the data foundation. So data foundation is really, we talked about all this data coming from different places. How do we pull all of that together into a format that can be used for doing analytics or for doing some kind of dashboarding and all that sort of stuff? And then on top of that, we build our own, on top of Predix, we build our own layer of transportation specific offerings, microservices for specific apps, rail related analytics, security mechanisms, creating data models and standards. In some cases, we are trying to push standards that will allow interchange of data between different railroads. So we don't want to just hog everything for ourselves, and a whole bunch of other services, right? So what ROS does is it kind of it's like the Salesforce model, right? Where you get the data ready, you provide APIs, you provide some certain standard capabilities, and let everybody come and build stuff on top of it. It could be us in some cases, it could be our partners in some cases, it could be you folks, you just go sign up and start building stuff. And then we do have a concept of a catalog where you can just put in your applications, people can start using it, and you get paid for it, right? So all of that comes with Predix, but that's sort of the goal, right? So what do we get? We get speed, we get a lot of innovation, because there's a common set of capabilities are already provided out of the box for you, right? So you just focus on, you think of some new app that you can build, just go build it. Don't worry about where the data is coming from, how will it be managed, who's going to take care of your all the benefits of cloud. And then innovation. So that basically, lets anybody, who has a good idea, come up and start building stuff. Right? So that helps with our, both train performance optimization solutions and the performance analytics. Right? So a couple of examples, right? So the edge innovation that I talked about. So we have a thing called Predix machine, which actually is a very stripped down version of the Predix stack, which can run on a Raspberry Pi, right? So you can actually take that, put it on a train, let that collect a lot of your data, right? And then let that data through GoLink, let it come back to the cloud and then we can do, for example, with the remote monitoring and diagnostics, a lot of the stuff they do is just streaming analytics. As the data comes in, they are basically viewing it as it comes in and looking at, even like with a rule engine or a decision tree, they can start saying, if I saw a bunch of these situations happen, maybe we need to alert about something like this may happen, right? So being able to do all of that and then you combine that with Predix, you can send alerts to your mechanic, you can send it to the service folks, you can send it to a dashboard that the manager is looking at. So a whole bunch of things start becoming possible because of all the underlying infrastructure. Another example is GoLink. So GoLink, we already talked about how it actually lets you collect data from a whole bunch of different places, right? But then you can also do things like once the data is collected and sent, in almost near real time, you have a bunch of analytics running in the cloud, constantly looking at the data as it comes in. And if you had that, if it figures out that, hey, so we have got a product called Rail Integrity Monitor, for example, which, as the train is moving, it actually figures out if there's any kind of discrepancy noticed in the integrity of the rail itself. Right? Now, if something like that is detected, you can do the analytics. You can say that, hey, it looks like there is a 40% chance that there might be a crack developing on this section of the rail. You could actually take that information and create a work order and put it in our wayside asset management system called RailDocs, right? So it will automatically create an order. The order will be sent to the inspector for that area. And next day when he wakes up, he looks at his thing, he says, there's a new inspection request, go check this out, right? So a lot of optimization in the operation sense, but then it all starts from data being collected from the locomotive. So these are things that we have done all of these things separately before, right? But putting it all together, and starting to, that's where you get the smart locomotive, the self-aware train sort of thing, where you will end up with a thing where trains themselves are monitoring themselves, they are taking actions by themselves, and in certain cases, yeah, they may ask for an override or something, but most of it is just happening on its own because the data is there, the infrastructure is there, and the knowledge is there within the train to do these things. Locovision is another, I talked about it. So this is an actual demo that we have where the train is moving and it can detect cracks, it can detect sun kinks because there are certain areas where if it's too hot, right, the track might expand or it might get deformed. How do you look at all of those things? How do you figure out if the gauge has deviated by the more than the allowed margin? So you can, and so these are all again things where if there is a derailment in the US, for example, it turns into a big audit kind of issue, right? So anything you can do to prevent those sort of things is it's really something that helps the railroad and the end customer in that sense, right? Now, and the last thing is, yes, on the ROS thing, right? So as we said, ROS will help you. It provides all the basic things you need to go and start building applications. So this is kind of a view of one of the apps that we are trying to build. I think we demoed this in InnoTrans in Berlin. So now that you have, like, imagine if you can take movement planner information, add it to Trip Optimizer, and then pull in some weather data, and then figure out. Sorry, ROS is the rail operating system. Right? That's what we are calling it. And so now you're not really worrying about Trip Optimizer is a separate product, Movement Planner is a separate product. We're just looking at how do we put all this information together to find the best way to go from A to B, at the right speed with the best fuel economy, but at the same time making sure you don't clog up the network, right? and you're taking all kinds of weather information, making sure you stop or slow down at high wind events, making sure if there is a, if we find some kind of natural effect or something happening, maybe a work order has come on certain part of the track, how do you reroute around it? So all of that stuff, when you start building it, and you have the capability now to, to start creating some of those apps, right? So that's when, people here will kind of come up and think, and that's what we find. We run hackathons, within our center, just for people to come up with ideas of things that can be done, right? And some of these ideas are just completely, there. I mean, you might have healthcare people telling, transportation that, hey, why don't you do this, right? So that sort of thinking becomes possible when you're able to also go off and try to implement some of these things. Just the standard thing behind hackathons, right? So that's kind of all I had. So what I'd suggest is, go, learn about Predix. Go to predix.io. It gives you a good foundation of, what the platform is, what it's supposed to do. Go check out GE Transportation site. Come work with us. I'm asking people to join us. Yeah, but I think it's I think IoT for a long time, and it's been there, right, as a term. People have been talking about it. It's probably gone through its hype phase already, and now it's coming back to the reality phase. But it is actually very, very cool, and the kind of things that you can do at places like GE or at Microsoft or places, the big guys, right, who have the data, they have the capability. I mean, that's where you can start really working on things that make a big difference. Right?
Do you standardize on the data models for all these vertical domains like smart transportation, etc.?
Correct. So there is no. So that's a very good question, right? Because there is no. There are not too many standards today. So there are few standards for, like if you're, like the American Association of Rail, right? They have some standards in terms of data interchange, but not a whole lot. I mean, there's no data interchange standard for how do you, send your health monitoring data or your movement planning data. All of that is not there. So we are trying to kind of influence some of that too, right? Because we have a good, big footprint in that space. Right? For Indian Railways, no, we are. So Indian Railways, so as you know, we won the big deal with Indian Railways in 2014 for 1,000 locomotives that we'll start delivering from next year. So this year end, we are going to finish the design and get it run it by the RDSO. So what we feel is things like trip optimizer, Locotrol, movement planner. These are all things that can be used out of the box, right? Some of the solutions we are building, the combined solutions we are building, we will be, again, we feel that those are not really, they are not US specific or it's nothing like that, right? We also want to build solutions that go beyond GE locomotives, so looking at the existing locomotive fleet that Indian Railways has. So again, we are talking to them about a bunch of different things, and over time we do expect that there will be a lot more stuff we'll do than just delivering locomotives for them. So a lot of our business is North America based, Canada, USA, and Mexico. Not that much, right? We have a couple of customers or few customers in. See, the locomotive footprint is global. We've got Africa, we've got Southeast Asia. In fact, Southeast Asia, all of the locomotive work is run out of Bangalore. In terms of design, maintenance, everything, right? Now the other things, some of these things are built for the US networks at this point. So there is work required to convert them. But all of the class 1 railroads in the US, there are 5 class 1s, they all use different pieces or multiple offerings that we have. And we also find that sometimes they go off and try to build these themselves, and they find out it's very difficult and then come back after a few more years. Yeah.
You give an example of wind velocity.
Yes.
Similarly, the climatic conditions are extreme in India itself.
Absolutely.
Whether it has been taken care when they are designing these smart locomotives?
Locomotives, yes. When we build a locomotive itself, we take care of, again, because there are requirements given by Indian Railways themselves.
The same train is going from
Yes.
Kanyakumari to Kashmir.
Yes.
Right via Rajasthan. Temperature fluctuations is so wide. Whether it is smart.
Yeah, see, the smartness comes not just on the train, right? It's the ability to send the information, get the thing done, and bring it back. A lot of things can also happen on the locomotive itself, because we have a very high-powered card on the train, which can run in analytics by itself, right? So it will take into account all those things. You know, like Locovision, you see a cow on the track. You know, Locovision has to know that, hey, there's a cow, better stop.
Bad luck.
Right?
To the cow.
But it will do it. You know, it will be able to do some of those things.
I think in the interest of time, we might want to take questions a little later. And last one, okay.
Last one for
Thanks.
him, right? Yes. Yes.
So now you are talking about predicts.
Yes.
Mostly going forward, synergy where they all converge or standardize the platform going forward.
Correct. See, the reason that, of course, you know, just to be clear, Predix runs on AWS today. Predix will be running on Azure, so we made an announcement a few months ago, right? So it's not that we are saying we are the only ones who know how to run a cloud. So we do have certain, so the cloud infrastructure that Predix provides, that GE runs, hosts and runs, it's highly secure, it's highly scalable, but there's also, you know, there are a lot of security and regulatory requirements that we manage, which may not be already available in folks like in AWS or Azure, right? So over time, I think that doesn't have to converge. You will probably end up with a whole bunch of offerings, and everybody uses the thing that they need. And there's enough, you know, there's enough. The pie is big enough for everybody to kind of, you know, have a share. All right. Thanks for your time, guys. I will be around if you need to.
Thank you,
have any more
Rishi.
questions.
And may I request Mr. Mahapatra?